an honor to be here amongst the students to talk about this particular topic. So let me jump in so that we can get you to Cinco de Mayo or your studies, whatever's next on your list. I'm talking about enhancing intelligence tradecraft, and obviously the tradecraft is really good as it stands. But there's some things that we can do with AI that may be able to help enhance that, and I'll talk about some of those today. Carla gave me a great introduction, so I can skip that slide. So what I'm going to talk about today is kind of two different sections. One, using Python and AI to process feeds, in this case, RSS feeds, but it can process anything. It can be websites, it can be Twitter, it can be, any kind of feed that we want. We want to be able to extract metadata from these articles or text. We also have to deal with things like multilingual processing. Not everything is in English. So we'll talk about that a little bit, talking about entity extraction and enhancement for people, locations that are mentioned within the articles, assess sentiment and threat analysis with AI, and then obviously the production of some intelligence reports that I'll show you. Shifting gears, we're going to actually advance to using agentic AI instead of traditional prompt response that we're all familiar with in order to be able to take this to the next level. And I'll be talking about that as well. So that's kind of a quick overview of what we're going to be talking about. So one of the questions you might have is, why do we focus on RSS feeds? Well, what you might not know is there's over 36 million websites that publish RSS feeds. It spans every domain of human activity, including news, cybersecurity, finance, etc., etc. Each feed includes key metadata so that you have a well-formed title, an author, a timestamp, a category, and then a link to the full article. Our AI models then can receive clean, context-rich, high signal quality content that's ideal for analysis translation. And I mentioned we can bring any kind of textual feed that we want into this, but I focused on RSS feeds because they're just massive that are out there that we can use, to basically test out our technology. So one of the things we want to do is entity profiling. In other words, who's involved in this particular article? One of the things that we are concerned about are things like the authors, the people, the organizations, and the locations that are mentioned within, let's say, an article or a post or that contact. So one of the things we want to do is we want to get information about the author. It's really important, right, to understand who's authoring this material, whatever it happens to be. And it can add value in analysis, but it can also add credibility to the process. So simply, I embedded an engineered prompt in Python script to generate author intelligence leveraging the OpenAI API. Now you might think, well, this is pretty simple. Just say, who's the author, right? Just a simple prompt. Well, unfortunately, that doesn't kind of get it done. So the prompt that I've created for this goes far beyond just saying who is the author and what do they do. We want to make sure that the AI conforms to, without hallucinating about what we're asking. So in this case, we want to provide the attribution of the author that is mentioned in the article. We want to make sure that we treat the URL of the article as the ground truth for the author. We don't want to merge information from authors with similar names. So we're asking AI to make sure, hey, if you're going to give me information about this author, it better be the author of this particular article. Information cannot be, if it can't be verified, then say unknown. So don't give us, guesses about this. Prefer primary sources such as the publisher's bio pages or institutional profiles in order to give us information about the author and then provide us great content. So how does that look in Python? Well, we take that concept and we turn it into a prompt that we can embed into a Python script. It looks like this. It's the same information. We have the author, the title, and the URL of the article. And then we basically want to have it follow some strict rules about extracting information about the author itself and then provide specific output. So if we put that into play, if we take a sample article like this one, and the author is Brian Krebs, that's the source of the article. That was the RSS feed. That's the actual title of the author article, and that's the actual article itself. So based on that, can we get information about Brian? And so the answer is yes. So the AI delivers all of this, basically giving us information that Brian is an independent investigative cybersecurity journalist. Many of you might have heard of him if you're doing work in cybercrime. And he's a well-known investigative journalist, been around for a very long time. I've known Brian for 20 some years on all these topics that he publishes. One thing I didn't know that AI returned was that prior to launching the independent site, he was a reporter for the Washington Post covering cybercrime. So even I learned something about Brian that I didn't know based on asking these specific questions. So then we want to know what the confidence is of this particular assessment, and it's high based on these factors. And so again, understand all of this came back from the response to the prompt that we generated. I also asked in the prompt, give me some related articles from this particular author so you could go look at those. So that's kind of thing that we can do when we're actually looking for information about entities that were involved in this particular article. One of the questions you might have is, wait a minute, what if the article and title and content are not in English? Well, we can obviously use AI in order to do the translation for us. So we can simply ask a question. We get the article and we can say, is the predominant language in this article English? Yes or no? And then provide the native text and then ask AI if it's a English article. If it's not English, then we can translate the article and get the English text. If it's already the English text, that becomes the native text in this particular article. So a very simple Python script to basically do that. However, one of the things that we want to be able to do in looking at articles like this is not only translate them. So I'm going to take a sample article. This was the Russian title, and this was the translated English title we used that code to do that, and that was the URL for the article. So we can basically get the title and translate that as well as the content of the article. So one of the things is, do we just translate? So one of the important things about translating is you don't want it to be the first step. You want to extract the linguistic signals from the native language of the article. So let's talk about why we'd want to do that. We must examine the native text itself in addition to the translated content, as translated content often contains translation bias. So let me give you the simplest example of translation bias. In certain cultures, if a person was identified in the article as a doctor, it's assumed he's a man. If it's a nurse, it's assumed it's a woman. Obviously, that's incorrect, right? So these translation biases have to be overcome. So we want to look at the native text and basically draw our own conclusions from those. Also, language carries intrinsic signals that exist independently of the metadata and the translated content. So we want to examine those as well. These signals are embedded in things like word choice, grammatical structure, stylistic consistency, and even the vocabulary that is used. So using an AI prompt, we can actually go in and say, I want to provide information about the native text. What was the likely language? Was the person that was writing this fluent in that language? What type of article is it? Is it journalistic, academic, bureaucratic? Is it a news article? What it happens to be. So we can get all of this information from the content of the native language of the article that we want to be able to use before we even analyze the translated portion of this. So we'll do the linguistic analysis of this particular article that I showed you the title in both Russian and English earlier. So it comes back, this call comes back now from the prompt that we generated with AI. The text is a news report written in the genre of an informational article. So it's telling us, hey, this article we're examining is a news report. This text is structured logically, so which is typical for journalistic materials aimed at promptly informing the reader. Also, the vocabulary and style. So when we're looking at the vocabulary, we want to know if the vocabulary is neutral. In other words, is typical for a news report is used to specify specific words that were used within the article that are important. There are no emotionally charged words or a subjective evaluation which corresponds to the style of reporting. So when you're writing news articles, you typically want to keep emotionally charged things out of the article. There's specialized terms and abbreviations like drones, Russian military defense, indicating the use of professional and administrative vocabulary. So we're getting a lot of information about this article even before we ever translate it. Talking about the sentence structure, it uses things like according to reports, as reported, transmits, as writes. those are ways to basically clarify the information that's in the article. In many sentences contain direct references. Again, this is from the native text that AI basically didn't translate for us, but basically pulled information from the native text. It has direct references of information sources, which kind of enhances the credibility and objectivity of the text. The headline and subline clearly indicate the topic and the timing of the events. The text is built according to what is considered the news paradigm. It's a way that we basically write news articles, right? The main event is, at first, the main event is briefly reported, then the details and comments from various sources are provided. That's kind of the traditional structure of a news article. They use temporal markers. Early Thursday morning, around 6 a.m., Wednesday, April 29, help organize information chronologically. That came from the article in the native text. Inclusion of opinions and reports from various sources, Telegram channels, official agencies, all of these provide a comprehensive view of the situation. Then there's some specialized vocabulary that was extracted from the article. You notice that I'm showing all of these to you in English, right? Because most of us don't read Russian. But what happened was when I got the results back from this article from the native text, and that was actually in Russian. So then I had to translate the lexical information so we could all, in fact, read it. The next thing that we need to do is take a look at the AI name entity recognition. This is called NER, name entity recognition. It's basically extracting and enriching information that's in the article based on the players that are involved, in the article. And those players can be a variety of things. We'll talk about those in a second. But by applying this concept of NER, we can move beyond passive reading and begin systematically uncover the who, where, and what matters. The distinction between reading content and extracting intelligence is not defined by the text, but rather by the intent of the reader. So the same article can inform, document, or reveal depending on who is consuming it and why. So let's take an example of that. Why is that? Well, if it's a media reporter, the concept is the reading is the primary objective. The article is the product. Names, locations, and organizations are included to provide attribution only. So that's what the media reporter is looking for. Digital forensic investigator are establishing facts in context. So in other words, if a digital forensic person is analyzing this article, their reading content is a means to corroborate or contextualize evidence. The intelligence analyst, on the other hand, which we're most concerned with here, is revealing hidden structure. So for an intelligence analyst, reading content is clearly insufficient. The article is not the product, it is the raw material. Every name, organization, location represents a potential node in a larger network of influences, activity, or intent. So again, the concept of extracting NER is important, but it depends on what you're reading this as. So what are the NTR categories? We're looking at people, and the individuals may represent decision makers, influencers, or even emerging actors that are part of this particular article. Organizations are typically the true drivers, the people that are influencing this content. These can include, corporations, military units, NGOs, non-government organizations, or advocacy groups. Locations are really important because they represent regions or facilities. Locations rarely are neutral in this concept. If locations are mentioned, they're there for a reason, and we need to pay attention to those. We want to extract those out from this. So in order to do this, what do? We build another prompt that will allow us to extract this NER from any article or any context that we bring into this, any feed that we want to be able to do. So we basically perform this name attribution, use the article as the text, treat the article text as ground truth. Don't merge information from entities with the same or similar names. Again, remembering there's going to be names in here, we got to make sure that those names are associated with this article and not just a common name that's being used. So we're instructing the AI to do that. If you can't verify this confidently, then say unknown, and then don't invent contact information. So that's what we're looking for. So this is what that looks like in Python. In other words, this is a prompt a little bit more complicated than what you typically type at the prompt, but this is the prompt. So we're directing what we want to identify: people, organizations, only use entities explicitly supported by the text, and we want information from the output. We want the names. We want if it's stated. We want to know if it's ambiguous. So in other words, if the name itself is ambiguous because we can't confirm the name, who that name belongs to, then tell us that it's ambiguous. And then we want to provide that information. So if I take an article, again, that was an article that was named A Broader Range of Issues, the third round of talks between Russia, Ukraine, and the US is taking place in Geneva. So that was the article that I basically applied that particular prompt to. So from that, it was able to extract first the people. And it doesn't just give us the name. When it can, it basically says what the affiliation is. It didn't know the background of Oliver Carroll, but it says its high authority is high based on the authoritative sources that were involved. This is the head of the president's office, de facto head of Kyiv's delegation in the talks, and it provides information about his role. I think it's a his. This is the NDS secretary official of Kyiv's delegation. This was the predecessor of the corporation scandal. Obviously, Vladimir Zelensky was mentioned, and Donald Trump was mentioned in the article as well, and it gives background in each one of those people. Organizational results. There were mentions of the British Economist, the National Security and Defense Council, and the United States. And again, it provides background of each one of those. So again, this is AI going out and getting information about those organizations that were mentioned specifically within the article and providing us with this information. Now, you may already know these things, but if you don't, in an article that you're analyzing, we can do that. And then finally, it gives us information about the locations that were mentioned and what its affiliation is, if it's a city, a country, and giving us information and background of those different countries. Okay, so basically, that allows us to get this NER, the name entity recognition, for any article or any text that we're accessing so that we can actually take it to the next level and get us information about those individuals, organizations, and locations that were involved in the article so that we can pull those out for the analyst. Next, we want to look at sentiment and threat analysis. So again, the ability to examine articles for threat and sentiment is really understanding meaning at scale. We want to understand what's actually this is about, whatever the text is that we're analyzing. Obviously, analysts are overwhelmed with articles and post feeds and reports, and hidden within this data are early indicators and emerging risks, coordinated narratives, geopolitical shifts. All of those things are part of the article, and we want to extract those out. And from a sentiment analysis, we don't want to just know if the article is positive or negative. We need more detail than that, right? So you have to evaluate tone, intent, emotional direction, and kind of the predictive awareness of what's happening within the article. So we also want to know if we're looking at threat now instead of this, we want to look at, is the conversation escalating? Are organizations or coordination? Is it positively, negatively, or hostile? From this perspective. When fused with entity extraction and enrichment, remember these things pull together, and threat scoring provides this immediate analytical triage that we can actually perform, using AI in order to be able to do that. Most importantly, this capability augments and does not replace the analyst. So the concept is that we can bring this information out quickly. The analyst can actually examine this for both sentiment and threat. So again, this article that just wanted to do the analysis of the same article that we did for the NER and looking at the sentiment and threat analysis. So again, I'm not going to have you read all this, but fundamentally, the point of this chart is that when we're examining sentiment, we're not saying, hey, I just want to know what the overall sentiment is, neutral to simple to slightly positive. But I want to understand what the breakdown of that is for each of the sections of the article, and does it change? And what are some of the emotional tones that are part of this? So what we get back from analyzing sentiment is not just positive or negative, but details of each section of the article in order to provide us with more detail so we can dive in deeper in looking at sentiment. The same thing goes for threat, right? When we're looking at the threat assessment of the article, we want to know if the article, the overview is positive or negative, but we also want to understand things like what are the impacts? What is the geopolitical tensions? What are the security concerns? What are the diplomatic and political risks? What are the economic implications? So we can get all of those things by asking AI to analyze this from a threat perspective. And we didn't tell it what part of the article to pull apart. It knew what part of that to go get to give us those results for each one of the parts of the article in order so that we can examine it for those important elements like security concerns and diplomatic and political risks and so on and so forth. So those are the things that we can get from actually designing a quality prompt that will extract information. One of the other things we can do with AI is to say, hey, is this article AI generated? And we want to understand if this was generated by an individual, an organization, or it was AI generated. And basically, again, it won't just give us an answer said yes. It just says this was AI generated or at least heavily assisted by AI. Several factors support the determination. So again, we get each of the factors that came into that decision, not just the overall decision. So you can make your own choices as far as whether or not how much of this or of this particular article was actually AI generated. And again, we can provide some additional insights into the article as well. So far, we've basically talked about things that you're probably very familiar with, using AI to basically define prompts. Maybe the prompts that I'm generating here maybe are a little bit more elaborate than what you do, maybe not. But so far, we're actually in that concept of prompt response. I have a detailed prompt that I want you to apply to this article or this set of articles, and I want you to basically provide that information. Now we want to move toward something called Agentic AI, which operates on an objective statement versus on simple, direct prompts that we want to get information, out of the AI. So Agentic AI refers to systems that can autonomously plan, decide, and then act toward a goal. So instead of answering a single prompt response, agentic systems operate more like I have a goal, I have a plan, I want to execute that, I want to evaluate, I want to adjust, and I want to continue. So something you'll hear as we move forward, large language models like OpenAI are becoming decision engines rather than just simply text generators. So the concept of using the model in order to be able to do something more significant than just prompt response and act on its own, and in some ways autonomously, which make people nervous, but that's what we're asking it to do. So what's the difference between traditional prompt response and agentic AI? Traditional prompt response are reactive. Agentic AI is proactive. Prompt response is single step. Agentic AI is multiple step. There's no persistence in typical prompt response, but Agentic AI uses memory and learns and actually takes that into account as it moves forward. Prompt response doesn't really take action, but Agentic AI can act. And traditional prompt response is prompt driven, and Agentic AI is goal driven. We'll talk about what that means as we start to build those statements. So agentic AI represents the shift from AI that answers questions to AI that can pursue objectives. So that's what we're talking about as we move to this next stage. So for the past several years, we've interacted with AI primarily as a question and answering tool. The environment is changing. Now agentic AI systems can pursue objectives rather than simply responding to prompts. So based on that, instead of asking AI to summarize an article, we can instruct it to monitor global feeds, identify emerging threats, profile actors, evaluate sentiment, and alert us autonomously. So I think you can kind of see the shift, right? We want AI to basically go out and gather information for us and then provide us with information that gives us what that threat level is, and what we should do with it. So as we look at these different articles, we want to be able to make that assessment, of them. So moving from prompt to delegation, instead of asking AI to analyze an article, we're going to give it an objective and let it decide what matters. right? So we're kind of giving up a little bit of control here. But if we construct our objective statements correctly, we can actually keep things still in control, but giving the agent the ability to move forward without us. So what does a simple agentic statement look like? So this is one that we wanted to build that basically analyzes articles that would be involved in, let's say, critical infrastructures or cybersecurity. So we want to, classify. The first we want to do is we want AI to basically, the agentic AI to classify each article that it examines as ignore, not relevant, monitor, useful but not urgent, or escalate, high signal threat intelligence. And so then we want to be able to extract from that, once we assess whether the article is in one of those three categories, we want to understand the sentiment, and we want to know fear, anger, optimism, hostility, who's concerned. We understand the linguistic identities that we talked about earlier. We still want those. We want to get that information. We want to know if the article was AI generated. We want to get information about the author and each of the names that are associated with it. We want the threat level. We want the author profile. We want all of that, right? So we want to build a objective statement that would basically provide that for us. So to do that, this is just an excerpt of the agentic statement that I just talked about. But I think I can shift modes here. Can I get out of the prompt? Yeah, I can. Okay. I think this is here. So this is what it looks like. I hope you can see this. This is what the actual code looks like for this cybersecurity objective statement. So again, oops, wrong one. The wrong side. Sorry. So this is what that objective statement looks like. Again, setting ignore, monitor, or escalate depending upon the article, and then identifying sentiment, the linguistics of the article, whether it was AR, we want the author profile, the name, entity recognition, and then we want to basically return all of these things. Now, in this example, we are directing AI to basically use this whole list of feeds and basically process every one of those feeds that we've identified that is related to the topics we're interested in. Okay. So we're giving it kind of a hint, if you will. These are the feeds that we want you to analyze in order to get that information. And then based on that, we want to generate the prompt and then extract the information and parse that output and give us some results. Okay. So that's great. So let me just pop through this. So this is what we get as an output, but let me show you this a little bit better form. So this is what it actually looks like when we get that investigative report about a whole set of articles that we extracted from all of those sources that I mentioned. So we get the decisions, obviously, if it's escalate, what the reason why it was escalated, what the article title is, who's the author, what is the NER. And you notice in these articles, there's a lot of name entity recognition identified within the article. We get the linguistic data that we're looking for. We're getting the sentiments was alarm, caution, concern for this particular article. And then it's unlikely that it was AI generated. And the native language of this article was German. Okay, so we're seeing everything that we've extracted here in English, but remember the linguistics was applied to the German text, not to the English text. And so now we can actually do that. So that was just the first one that we looked at. And this one was escalated. This was English. This was a North Korean Nexus a threat actor compromise. These were the authors were Mandiant, obviously an authoritative source, and these were all the NERs. These are the attributed language. This is the alarm, concern, urgency, were the threat levels that we're looking at from that perspective. So this is the kind of thing we get for every one of the articles that we examined. And you can tell a lot of these were in the escalate category. So this is what we're able to do. We're able to apply this particular objective statement to thousands of articles and then get the ones that are escalate and provide that information to the folks that are looking at that information and want to understand, how to take it to the next level and which ones are concerning, let's say, to their organization. So the so I want to give you an example outside of this so we have enough time for some questions. But so that's what we're getting from the AI cyber threat output based on that agentic AI statement. So I wanted to do something outside of cyber, right, which is kind of our focus a little bit. But I wanted to do something outside of that because there's other things happening in the world that are important as well. So this was a disaster objective. I'm going to show you the whole one in a second. But this is basically, we're looking for articles and news reports that relate to natural disasters, humanitarian agencies relevant to humanitarian aid, such as the Red Cross. Your purpose is to discover content of human suffering, urgent needs, population displacement, etc. So we want to basically build one of those. However, if I want to show you what that really looks like, give me one second. Get my screen cleaned up here. This is what that objective statement looks like. This is much more complicated than even the cyber one was because it's giving that same information that I had in the slide, but it's also saying, I want you to focus on events such as hurricanes, tropical storm typhoons, tornadoes, floods, wildfires, tsunamis, giving them specific examples of what I want the agent to basically go look at. And I want to give special weight to articles that suggest death or injuries or evacuations or displacements of families. Those are the categories that we're interested in looking at. You should prioritize the discovery of articles that would help a humanitarian organization to answer questions that where are people most at risk? What type of assistance might they need? So we're looking for those kinds of answers. So, and it goes on to basically be as specific as possible or the kind of information that I want to get out of this. The other big change in this objective statement and how we're processing it is it's the same as before. Decision is ignore, monitor, escalate, and then it's going to give us the hazard type and all of the other information we ask for. However, in this particular case, we do not provide the engine, the agent, a specific list of RSS feeds or URLs to process, but rather we ask to perform the discovery based on that objective statement, and we say we want you to do a web search. And then we just limit the number of responses we get from the web search in order to be able to do that. So the distinction between the global disaster agent and the cyber agentic AI agent in the cyber agentic AI is we're directing specific RSS feeds to be processed. In this particular example, we're saying anywhere in the world on the web, go get that information and give us those results. So what does that look like? So again, similar to the report that we got for the cyber intelligence, this is what we have, but obviously the results are different. These are escalates, what the hazard was, cyclone, earthquake, flooding. Where is it? You notice that the locations are all over the world. So the agent was able to go out and find issues related to cyclones and floods and wildfires, tends to be in the United States, but all over the world. And what was the impact? There were 41 deaths, there's a dozen people were killed. All of these things that are specific to the impact of people, the impact to infrastructures, um, the indicators that were found within those particular articles. And then the urgency level, whether it was high, medium, or low. And then what was the actual URL of the article if you want to go look at that in more detail. So again, all of these came back as escalate, and some of them came back as monitor in order to be able to see that. So I wanted just to show you that we can apply this technique of building agentic AI objective statements beyond just cyber or, from an intelligence point of view. And you might say, well, wait a minute, this kind of disaster thing doesn't really apply that much to intelligence, but it sure does, right? If there's things that are going on in the world that are disasters, it actually does in fact apply to what, we're doing. So let's talk a little about the future, then I'll open it up to questions. I think I'm just about right on time. So the future, according to Chet, where do we go from here and what's going to happen? Well, the future of open source intelligence. Remember, when people talk about OSINT, right, it's open source intelligence. And a lot of the work that's being done in open source intelligence today is really open source information collection. We want to basically move that to, hey, give me the intelligence that comes out of that open source information. So today you saw how we can convert raw feeds into operational intelligence, how we can automate the translation of multilingual content while preserving the native language signals. We can extract author and entity enrichment details. We can detect narrative shifts that identify threats and sentiment. We can analyze global content in near real time, and we can autonomously assist the analyst using agentic AI. So that's the whole concept. We want this to work autonomously and then deliver quality information and content to the analyst. So again, from RSS feeds to autonomous intelligence systems, traditional OSINT, the past static RSS ingestion, human-driven analysis, limited scalability. As we get into augmented pipelines, we can process those, and then when we get into agentic systems, we can actually process those and deliver the concept, decide, coordinate, and evolve, so we can rank those things that we should be looking at. So we're no longer just analyzing information. We're building systems that participate in intelligence ecosystems. So the advantages no longer belong to the organization with the most data. Instead, it belongs to the one that understands it first. And so a lot of this automation that we're trying to put in place is to deliver that statement, to make sure that we have all this information, but we want to be able to understand it. So here's my prediction for the future. I predict AI will not replace the intelligence analyst, but intelligence analysts who leverage AI will replace those who do not. So thank you for your attention, and be happy to answer any questions. Again, I wanted to get through all that material so that you guys could ask some questions, and then um, I can respond to those. And I don't know if you wanted to read those, Carla, or should I try to find them myself?
Sure, yeah, no, I'll go ahead and read it. Chet, thank you so much. Let me start here. So, how can agentic AI employed by bad actors to push disinformation or oversee active measures campaigns be effectively countered in your experience?
Yeah, so it's a great question. And one of the things that I've been doing lately is to integrate more information within the objective statement that will eliminate some of that content that is let's say, not accurate or has been manipulated in order to be able to move the opinion in one direction or the other. So the concept is that building these quality objective statements is a process. And I think it's a process that we're all going to be involved in as we go forward. And it's a great question because as much as I'm asking the agentic systems to give me information, I'm also, as you probably could tell throughout the process, is asking questions to say, hey, stay on track. Don't go and give me information about people or organizations that are not real, and provide this kind of vetted information back from AI. You can't, what I've learned is, it's a great question because what you can't do that doesn't work is go in and put something in the objective statement like, hey, don't hallucinate. Okay, that doesn't work. You have to get much more specific about what do I want you to deliver and what I don't want you to deliver to me. So you got to give it those kinds of um, specific rules or guardrails that we're going to put inside the objective statement so that we don't get information that is either misleading or misinformation. I hope that answers kind of the question that was there.
So, Chet, we have a question here that a student submitted by email earlier, and then we'll come back to the chat.
Okay.
So the question is, with the rise of agentic AI, how do we prevent investigators from blindly trusting in their investigations and still ensure its results are reliable enough to use as evidence?
It's another great question, and it really goes again to the careful curating of the objective statements that you're there and making sure that those guardrails are in place to basically eliminate, speculation. We've talked a lot about today about making sure that we've identified the right person. when we get into things like imagery and that kind of stuff, and knowing that there's a fake photo or if it's real, how do we analyze that? Those things will come into play as well in order to make sure that we're evaluating the evidence accurately. And asking, in the case of evidence, you're going to be asking the AI, the agentic AI, if you're doing it right, you're going to be asking the agentic AI system to provide inculpatory as also exculpatory evidence from the data that's provided. And so one of the big problems today is we tend to focus on getting to the answer, who did it, and we want evidence to show who did it. But we don't spend maybe enough time in looking at exculpatory evidence that would basically exonerate someone or provide other information. So those kinds of specifics when you're dealing with evidence have to be built into the objective statements to make sure that it comes back as well.
Okay, so we have a couple of questions here. So how should analysts connect cyber indicators to information operations, information warfare activity without mistaking correlation for attribution?
Yeah, that's another really good question. So remember the what we're at the stage that we're at right now with agentic AI, it's to parse and provide um, accurate information to the analyst, right? Not necessarily to make a decision, an ultimate decision. That still has to come down to the human analyst. And so the AI systems can provide quality information, and we can ask other questions that will basically dive into the details of what we're analyzing in order to get additional information back to help humans analyze that. Now, once we do that, and once we've been getting really good at taking the information that's coming from the agentic AI system, and then we basically process it as humans, we can use that feedback loop to include other questions or guardrails into the objective statement that will make it possible so that in the future we don't have to do so much human work in order to get to those correct decisions. So that's kind of where this feedback loop has to happen as we all start the process of building better and better and better objective statements that drive agentic AI. It's not one and done. We build these and then we go back and we revise them based on the information we're getting back. And I think that that's a real key because, being a computer scientist and have been writing code for 40 some years, one of the things that I've realized in writing the book and working on this over the last couple of years is that we're no longer going to be writing code. We're going to be writing quality objective statements that allow us to use AI to extract the information we need. So there's a paradigm shift happening in computer science that maybe a lot of people don't want to agree with, but I see that coming. So I know that was a longer answer than maybe was necessary, but I wanted to make sure that that got out there.
So with translating to English, Russian cybercriminals utilize slang very heavily, which is impressively colorful compared to English slang, which even with guardrails can be difficult to see through. Do you have any recommendations for controls or audit capabilities to prevent potential critical data from being mistakenly rejected by the agent if it doesn't understand nuance like this?
Yeah, it's a really good question. The point is that looking at, one of the things that I covered early on in doing the translation stuff is that we have to extract information from the native language first and then translate. And I think that's really important. Then compare both of them. And I think it's really interesting that you mentioned that because there's based on my background in steganography and data hiding, there's the other issue with foreign languages, the embedding of information within the foreign language content that gets filtered out when translation occurs. But that information that was in the native language is so important because that's where the hidden content may be. So there's this other element of foreign language usage that basically is being used to basically communicate out of band. And we want to be able to identify that. And that's why I keep stressing that we have to look at the native language first and extract all of those characteristics of the native language before we translate and then do the work on the translated language. So that's the first step. And I'm not saying that's the holy grail, but it is certainly something that we have to really pay attention to.
All right, thank you, Chet. The next question. So, with AI becoming more integrated into intelligence workflows, particularly for collection and data exploitation. Did I ask that one before? No, sorry.
No, you didn't.
What safeguards are being developed to protect these systems from adversarial manipulation, data positioning, or other attempts to corrupt the analytic architecture?
Yeah, we're facing that now, right? You know, the bots that are out there today that are basically influencing everything that we look at out there, whether it's from social media or from the news or from foreign language, etc. And the ability to identify something that was generated by a bot versus something that was generated by a human or a journalist is really important. And so one of the reasons that I integrated into some of my more recent objective AI statements, actually you saw that today in the cybersecurity one, is I want to know whether or not this article or this content, whatever the text was AI generated or was it generated by a human? Because that's our first indicator that this could be problematic. If it wasn't, you know, generated by a human but was rather AI generated, then we have to become suspicious that this is trying to manipulate the world, right, and everything that we do. And so that's one of the things that we have to make sure that we place in all of our objective statements is to determine whether the content is accurate, it's verifiable, and it's not purely AI generated.
Are all of your AI resources coming from OpenAI API, or are you utilizing locally ran open source models? Are different models chosen for different languages since some models are better than others for different languages?
Yeah, the so to answer the first part of the question, all the examples that I showed you today were from OpenAI. However, the issue is that again, if we build quality prompts and objective statements, they can be run in any model. So if you have another LLM that you want to basically run these objective statements in because it has certain characteristics that would be better for whatever your intelligence operation you're doing, then by all means do it. Again, the examples here were from OpenAI. So, but this is kind of in many ways, a universal language now in building prompts or building objective statements. They can be plugged into any LLM that you want. And I think that's a really important benefit of focusing on developing and curating high quality objective statements that have guardrails and have some of the things that people have been asking to make sure they're in there, because then you can bring them into any LLM you want.
Any other questions for Chad?
I should say these are all great questions. I mean, these are exactly the kinds of things that I deal with every single day. And so they're right on point of the things that we need to be considering as we integrate more AI into what we're doing, whether it's in digital investigations or whether it's in intelligence. All of those questions are really important. Like, for example, I'll give you something that you may not know what's going on, but one of the real things that are happening in digital investigations is digital investigators collect information from everything. And one of the things they're collecting is information from prompts. So they want to know what prompts individuals are using if they're investigating them. So they're basically mining the prompts that they basically used with AI to determine what they were doing. So the whole nother thing is looking at how people are using prompts and what their overall objective is. So just kind of keep that in mind. It's just kind of an interesting area of research. Yeah, yeah, exactly. A remote, yes. Counter prompt operations.
Any other questions? If not, okay, we do have one. If, as you have predicted, the job market shifts toward objective setting, what skills should students prioritize alongside Python to stay competitive?
Yeah, it's a really good question, and I'll tell you, I'll give you an answer that's not directly to that, but it kind of relates. When I was first starting to develop software a long time ago, I asked my boss at the time, who was a brilliant guy, hey, how do I become the best at this? And his answer was really simple and said, do it every day. And so it's the same answer to this question, but for a different purpose. So write objective statements every day, write high quality prompts with guardrails every single day and experiment with them. And so it doesn't matter if you have a need for that day, but do it every single day and you'll become really, really good at it. And that's the skill people are going to be looking for, is those that can actually not only generate or use AI or use LLMs, but generate high quality prompts for objective statements. So I just saw the question came up
Yeah.
about whether I would be willing to provide the Pi files in the in the code today. I would normally just say yes, and I would do it. However, all of the objective statements and the Python scripts that I use for this are in the book, and that will be out within a week. And then I know what happens with you guys is that the publisher that I'm using, Apress, basically will turn those into um, O'Reilly books. So most of my books are already in your library as O'Reilly on the O'Reilly side, so you'll be able to get those. In addition, you'll be able to get to all of the scripts and objective statements because they're going to be in A-Press's Git library. So you'll be able to get those even if you don't buy the book. I'm not trying to sell the book. I don't make any money on the book. But if you know anything about authoring books, you know the author doesn't make a lot of money. But they have a Git repository, so all of the scripts and objective statements that I've developed for the book will be open source. Short answer to the question. So, sort of yes, I don't have any problem providing it, but we have to wait for the book to come out within a couple of weeks, and then you'll be able to access those.
Right. So part two of that question is, what Pi artifacts or code snippets do you see yourself reusing with regards to AI into investigations?
Yeah, the answer there is, as you start to build better things like not only what you're looking for, but the guardrails to prevent bad information from coming back, those sections of the objective statements and the prompts are something that you're going to store away and reuse. So you tend to be looking for different things, so you have to write those parts of the objective depending on what domain you're working, but you start to build better and better parts of the objective statement that are the guardrail portions of it, and making sure that the LLM doesn't provide misinformation or doesn't miss anything. So though those, as you start to build those and they become successful, you'll put those in your library and reuse them as you build new objective statements or prompts. Yeah, that's a really good question. So, if you're interacting directly with ChatGPT or OpenAI, you can create projects and put those in there. Then you can basically go back and other LLMs do it similarly. If you're using, Claude or something like that, those have the ability for you to basically use the LLM itself to kind of store and categorize those kinds of content. So work within the library you're using, whether it's OpenAI or ChatGPT or Claude, whatever it is. Those platforms provide a vehicle for you to basically store your prompts in projects, if you will.
All right. Any other questions? Okay. If not, Chet, thank you so much. That was amazing. We always learn so much from you, and thank you for sharing your expertise, your knowledge with us today. And everybody that joined, thank you. I have IC scholars here, students I have, our advisors, faculty. Thank you all. And I know students, you're all busy. Finals are coming up, so good luck wrapping up the semester. Congratulations on another academic year. And we will have the recording shared with you all soon. So we'll share that by email. I know a lot of you asked and sent us emails earlier asking about that. So we will share that with you all. So thank you again.
Yeah,
Chet, is
and
there anything else?
final word for me. Thanks for
Of
everybody for your
course.
questions and thanks for participating. This is such an important concept. So I applaud you for showing up, especially on Cinco de Mayo.